हरि करना।
Now it's time for chi-square test. So the chi-square test is a statistical test that is used to determine the association between two categorical variables. It's a non-parametric test, which means it does not assume any specific distribution of the data. Non-parametric test means which means it does not assume any specific distribution of the data. Let me write it down. There is parametric and non-parametric, two types. Okay, parametric versus non-parametric. So most of the distributions, most of the tests are parametric. If those are parametrics, they look for the some specific distribution of the data. Anyway, non-parametric means it does not assume any specific distribution of the data. So the test is based on the comparison between the observed frequencies and the expected frequencies. Very important. The test is based on the observed frequencies and the expected frequencies. We have discussed about this chi-square test, and we have uh, built a chi-square distribution altogether in the previous course, that intuitive sampling and distribution. If you want, you go there and watch, and later you can watch this video. So now the expected frequencies are calculated based on the assumption of independence between the two variables. So the chi-square test is used in a variety of applications such as market research, social sciences, medical research, and quality control. And it's also used in machine learning and data mining to determine the significance of association between two categorical variables. So why we use this chi-square test in machine learning and data mining? To determine the significance of the association between two categorical variables. So now let's look into the various steps to be followed to do this test, to do a chi-square test, to conduct a chi-square test. So step 1, formulate hypothesis. The first step is to formulate the null and alternative hypothesis. The null hypothesis states that there is no association between the two categorical variables, while the alternative hypothesis states that there is a significant association between two variables. And second step, collect data. The second step is to collect the data in the form of a contingency table, which is a table that shows the frequencies of the categories for each variable. So then third step, it's a very important step of conducting a chi-square test. That's calculate the expected frequencies. So the expected frequencies are calculated based on the assumption of independence between the two variables. This is done by multiplying the marginal totals for each row and column and dividing by the total number of observations. So then The most important step, calculate the test statistic. The test statistic is calculated by comparing the observed frequencies with the expected frequencies. This is done by summing the squared differences between the observed and and expected frequencies and dividing by the expected frequencies. So the resulting value is compared to a chi-square distribution with the following degrees of freedom. That's r minus 1 multiplied by c minus 1 degrees of freedom, where r and c are the number of rows and columns in the contingency table respectively. So this is what we call as a degrees of freedom when it comes to the chi-square test. So I'm repeating this step one more time because this is very, very important step. First, we have to calculate the Pearson residue, Pearson residual. So that can be calculated using R is equals to observed minus expected divided by square root of expected. Once you got R for each one, so for each category, then let's calculate the chi-square statistic. So which is defined as the sum of the squared Pearson residuals. So then you square it off each and every residual and then sum it up. That's what is your chi-square statistic. I'm repeating again this step. The test statistic is calculated by comparing the observed frequencies with the expected frequencies. This is done by summing the squared differences between the observed and expected frequencies and dividing by the expected frequencies. The resulting value is compared to a chi-square distribution with degrees of freedom, where r with the degrees of freedom of r minus 1 multiplied by c minus 1, where r and c are the number of rows and columns in the contingency table. So next, determining the p-value. The p-value is calculated based on the chi-square distribution with degrees of freedom r minus 1 multiplied by c minus 1 degrees of freedom. The p-value is the probability of obtaining a test statistic as extreme or more extreme than the observed statistic. So assuming that null hypothesis is true, then make a decision. Conclusion: if the p-value is less than the significant level, typically 0.05 or 0.01, the null hypothesis is rejected and it is concluded that there is a significant association between the two categorical variables. Otherwise, the null hypothesis is not rejected and it is concluded that there is no significant association between two variables. So as an example, so let me write it down. Chi-square test. As an example of the chi-square test would be to determine whether there is a significant association between gender and smoking status. Significant association between the gender and smoking status. So the null hypothesis would be H0. The null hypothesis would be there is no association between gender and smoking status, while the alternative hypothesis would be there is a significant association between the gender and smoking status. So the data would be collected. Next step, the data would be collected in the form of a contingency table with the rows representing the gender. So then next step is to collect the data. So collect the data. Let me put it here. Now let me collect the data. This is first one is done. Now step 2, collect the data. Now how do we need to collect the data? The data should be collected in the form of a contingency table. Contingency table. Our contingency table will consist of the rows representing the gender and the columns representing the smoking status. Let me do that. So rows representing the gender and then columns representing the smoking status. So for me, I'll have a male and then female here. And then on top, I'll have smoker, non-smoker, smoking and non-smoking, or whatever it may be. And here you will have the frequency of each. Okay, so once this is done, the data, once the contingency table has been created, so the expected frequencies would be calculated based on the assumption of independence between the gender and then smoking status. So the test statistic would be calculated by comparing the observed frequencies with the expected frequencies. So then the following steps should be followed. You have to calculate the Pearson residual for the each cell of the contingency table. Then R11, R12, R11, R12, R21, R22, and then square and do square of each cell R and sum it up. Then you will get the chi-square statistic. So once you get the chi-square statistic, the p-value would be calculated based on the chi-square distribution with the degrees of freedom r minus 1 times c minus 1 degrees of freedom. If the p-value is less than the significance level, the null hypothesis would be rejected and it would be concluded that there is a significant association between the gender and smoking status. Now let's take the simplest example. Okay, let me write down here similar kind of one. So let's import numpy as np and then from scipy dot stats and import chi-square contingency. That's it. Now let's define the contingency table quickly for the same thing approximately. Now I'm just defining the contingency table. So define contingency table. So observed is equals to, this is observed one, observed frequency, not the np of array. And two lists, first 100, 100, let me take the 150, that would be fine, and 5050. Then I got 200, 200, 300, then 100. So our contingency table is ready. If you want to check, you can check observed, and this is what is your contingency table. Next. So next is to perform the chi-square test. That's it. Perform the chi-square test. So chi-square and then p and degrees of freedom and expected all together. Expected. So chi-square contingency and put it in observed, and that's it. I think all ready. So now it's time to print everything. So let's print the results. All done. Let's print the results pretty fast. So print chi-square statistic. These are chi-square 2. Next, print and p-value is p. Then print degrees of freedom is our DOF. Then print expected values is expected. That's it, all set, all done. So here is your chi-square statistic. It's 0.0 and p-value is 1.0. Okay, this is too much. It's too much. And degrees of freedom is 2. Your p-value is 2. So if your p-value is 2, what's going to happen? Let me explain. So in this example, what we did so far is, in this example, we have a 2 by 3. It's 2 by 3. You can see the shape. 2 by 3 contingency table where the rows represent two different groups which are female and male. And the column represents three different outcomes. Smoker, non-smoker, and then other one would be drinking and smoking together. Okay. Now, these are the three. Let me put it one more. No, I'll put it weed and ganja. Weed and ganja go together. So total 3 sections. This is just normal smoking and it doesn't smoke anything. And this guy weed, ganja plus cigarette all together. All together, cigar. Okay. So this is what our contingency table with 2 rows and 3 columns that represent three different outcomes. So now the observed array contains the observed frequencies from each group and outcome. So now we use the chi-square contingency function from scipy.stats performs the chi-square test and returns several output. So which consists of chi-square. This is the chi-square test statistic value. I don't know. It's given 0.0. Maybe the issue with the data. That's okay. Still fine. Then we got the p-value. The p-value associated with test statistic, I got 1.0. This is huge. Then DOF, that's a degrees of freedom, which is nothing but the degrees of freedom for the test. Let me show you the formula first. It's 1 minus r minus 1 times c minus 1. So r minus 1, 2 minus 1, 1, and c minus 1, 3 minus 1, it's 2. So 1 times 2, it's 2. That's it. That's your degrees of freedom. Then finally you will get an expected values, an array of expected frequencies under the null hypothesis. And these are what the expected frequencies. So we can interpret the results. Let's interpret the results here. We can interpret the results of the test to determine whether there is a significant association between the groups and outcomes. So if the p-value is less than 0.05, this is our chosen significance level. If which is less than that, we can reject the null hypothesis and conclude there is a evidence of a significant association. But what we got is p-value for us is equal to 1.0 and level of significance level at SL, or let me say alpha is equals to 0.05. So now it's clear that p-value is not lesser than alpha. Hence we failed to reject the null hypothesis. And conclude that there is evidence of no significance association. That's it.